we had 5 or 6 characteristics here. Okay? First thing, we said about the base. We didn't put it under characteristics, but we did mention the base. We said it had to be positive, it couldn't be 1. Remember, we don't do -2 to the x power. That has a weird domain. Okay? So over here, when I do y equaling the log base a of x, then before we do the characteristic of base a, it has to be positive, and it's not allowed to be 1. Same requirements. Okay? So that's nice and consistent, right? Okay? When we talked about y equaling a to the x, I said there's 3 points that I'm going to want you to plot. What are those 3 points?
0, 1.
0, 1.
1 base.
1 comma a and
-1.
reciprocal of a, right? Okay? So it was the first characteristic. When I do the inverse, I switch x's and y's, right? And I'm going to tell you this. In all the years that I've done mathematics and taught it and done whatever, I have never truly memorized these 3 points. Okay? I've memorized those, and then I remember to switch them for the log. Okay? So if I switch the first one, instead of going through 0, 1, it would go through 1, 0. That's a lie. Actually, I remember that one. But the others I don't. Okay? Instead of going through 1a for the exponential, the log would go through a comma base. Yeah, I mean a comma 1, base comma 1. And then switch those two, it's the reciprocal of the base comma -1. Okay. Next property. We said the domain of the exponential function was all real numbers, and that the range was 0 to infinity. No matter if it was an increasing or decreasing function, right? It didn't matter if I was doing this or if I was doing this. The domain was all real numbers and the range was from 0 on up, right? With inverses, we switch. Doesn't matter if it's increasing or decreasing. The domain of any log function is 0 to infinity, and the range is all real numbers. Just want to emphasize that again. Okay. Now, here is one thing that's going to bother some of you. It's going to confuse you. Can I take the log of a negative number? But can the log be a negative number? Is this possible? Is it possible for me to say that the log base 4 of 1/16 equals -2? Is that legal? My log can equal a negative number. I just can't plug a negative number into the log. The range is all real numbers, positive or negative. The log can end up being, and could the log even be 0? Yeah. In fact, that was one of the properties. The log base anything of 1 is 0. So this is okay. But to do this is not okay. Alright? Okay. Does anyone remember another characteristic of the exponential function? Lots of paper turning. Nope, there they go. Another characteristic of the exponential function. Before the asymptote, if the base is bigger than 1, if you have a relatively big base, what kind of function does that give you? That's an increasing function. one that looks like that. And if you have a relatively small base in between 0 and 1, that got you a decreasing function. Like that, right? You know what? These are identical, almost, but the graph's not identical, but this property is identical for your logs. If you have a relatively big base, if a is greater than 1, it's an increasing function, but instead of looking like this, it's going to look like this. And if you have a relatively small base, like log base 1/3, then you have a decreasing function. And it'll look like that. And then the last chunk, the last property that we talked about for exponentials is the horizontal asymptote. We said the x-axis was a horizontal asymptote. Okay? You do an inverse, you switch x's and y's, you switch horizontal things with vertical things, and all of a sudden, now it's the y-axis. That's a vertical asymptote.